Hi, gentlemen. I just want to go through what you're going to be doing for this lab, what you're turning in, and what you are doing with your data. So hopefully you've already read through this letter and you understand that you're a lab company, and you're helping out Underwriters Laboratory, which is a huge corporation that accredits laboratories or tests products for safety and to see if they are doing what the product claims they're doing. So they have their hand in a lot of things that have to do with laboratory work. Sometimes they ask for other private laboratories to help out. That would be being part of a standard technical panel, and that's what your company is doing. So ultimately, you're going to have to refer back to this density table to identify what the unknown substance is once you have your slope, because slope is equal to density. Click on the graphing handout in the directions. This explains what a characteristic physical property is. You should make sure you read through that. And then once you develop a quick procedure with your classmates and collect your data in this data table, you can then start your graph. So make sure you're only graphing the mass and the volume. The volume is on the x-axis. So when you make your table, the first thing you're doing is labeling volume in milliliters and mass in grams. These two columns in the center were needed in order to get the volume of the metal. We don't want to graph anything about the volume of the water. We used that water in order to get the volume of the metal. So there's only an X and a Y. Do not do anything further with these columns once you've subtracted and have the volume of the metal. All right, so this tells you your basic steps. You're going to label your graph, as I just said, with mass and volume and the units. Then you're going to figure out your coordinates or your axes values, the increments that you're going to label on the graph. One trick is to take the range that you have of, say, the volume, and then count the number of spaces on your graph, blocks on your graph, and then divide. If it comes up to 1.6, then you know each block is going to be 2. You don't want to go lower, you can only go higher. If you round down to 1.5, then you're not going to make it to the end. You're not going to make it far enough. So round up. Or you could do the guess and the test method, but I would suggest dividing works better. I think I wrote that down here. Yeah, that's number 2. Divide the range by the number of blocks. Okay. Make sure 0 is at the corner. Plot the X, Y. Do not plot the water data. Draw a best fit line starting at 0 and pivot that line. Make sure it's very straight and make sure it's an average. So the same number of points above and below the line, making it an average. When you find your slope, you're going to mark 2 points on the line. Use a nice thin line too. Best to use a thin line, less error. And then mark those points with an X or circle or something like that on your line, and then label the coordinates right next to it. And then where you're showing your calculation, show your change in Y over change in X. Put it in decimal form, and the units for density, because your slope is density, is grams per milliliter. Then consult your table that I showed you a minute ago and find out what your unknown metal was. Lastly, your report is really just going to be a letter back to Underwriters Laboratory. Explain all these things. Don't forget to answer this question in A. Why did you use density instead of color to identify the substance? Explain the procedure in 2 sentences. It's not a lab report, it's just a letter, so 2 sentences will cover it. Identify the metal in the letter. State the slope, which is the density. State the percent error, even though you're showing your calculations elsewhere, state it in the letter. Identify reasons for error. 2 reasons should be fine. And 1 conclusion sentence. thanking Mr. Anderson for letting your company participate in this program. So professionalism is what we're looking for. All right, and submit the graph calculations and the letter to your teacher. All right, I think that's it. Ask your teacher if you have any further questions. See ya.